Okay, we're going to look at something called the counting principle. With the counting principle, we're going to be able to tell how many potential options there are for each situation. Let's take a look at an example. Let's say a school team sells caps, baseball caps, in two colors, blue and white. For each color, there are two sizes, child and adult. And in each case, there's also two fabrics, cotton or polyester. Let's see if we can figure out how many possible cap combinations could be ordered. Let's begin with the colors. We have blue and we have white. Now for each color, you can order that hat in two sizes, either child or adult. So for blue, there's child, and for blue, there's adult. Same thing with white, child and adult. Now whether it's a child or an adult, or blue or white, you can also order the hat in either cotton or polyester. So for each blue child hat, we can get cotton or polyester. And for each blue adult hat, we can get cotton or polyester. And the same goes for the white. Now each branch in this tree represents one option. If I want a blue child hat that's cotton, that's one option. If I want a white adult hat that's cotton, that's another option. So in order to figure out how many potential options we have, we need to count where our tree ends. Counting each C and each P at the end of our tree, 1, 2, 3, 4, 5, 6, 7, 8, we see that there are 8 different options for a hat for this fundraiser. Using a tree diagram would be very useful to find the number of options. It's very visual and you can see what each option is. However, the more options you add, the more options are available in the end. So you could end up with a very large tree. So let's take a look at something called the counting principle. And basically it says, if there are m ways to make one choice and n ways of making a second choice, then there are m times n ways of making the first choice followed by the second. And here's what it says. It says there are m choices that can be picked first. The second choice could be n, and so on and so forth. But if we wanted to know the total amount, we just take our options and multiply them. And that will give us our options. So let's take a look at what we just looked at with the baseball caps. For our first choice, we had two options, blue and white. Our second choice, we also had two options, whether it was going to be a child or an adult. And we actually had a third option. We could keep going. Third option was cotton or polyester. There were two. So according to the counting principle, we take the options available to us and multiply them together. So 2 times 2 times 2, and we get 8. So we can figure out how many options there will be without drawing this large tree like we did in purple. Okay, let's take a look at an example. How many two-letter monograms are possible? Monogram might be something like KM, 2 letters. These would represent my first and my last name. And it might be something I would get embroidered on a towel or a piece of clothing or a hat or a jersey. So we want to know how many possible combinations that look like this are available. How many are out there? Well, if we're talking about letter combinations, how many letters are there? There are 26 letters. So for our first letter, how many options do we have for that first letter? We have 26. For our second letter, how many options do we have? Well, we can use the same one twice, M and M, S and S, T and T. So we still have 26. So to figure out the total number of combinations available, we are going to take 26 times 26, and there are 676 possible combinations of 2 letters. Let's take a look at another example. How many 3-letter monograms are possible? Well, again, 3 letters. Here's an example. For our first, how many choices do we have? 26. Our second, again 26. And our third, 26. Multiply all of those together. There are 17,576 options for a 3-letter monogram. One final example. How many 5-letter license plates can be made if the letters O and I cannot be used? So we are looking at a 5-letter license plate. So let's just, for an example, A, B, C, D, E. There's 5 letters. So there are 26 letters in the alphabet, but we're going to minus O and we're going to minus I, which means that there are only 24 letters left. So for here, there are 24 options. For B, or for your second option, there are 24. For 24, 24, and 24. Multiply those together. 7,962,624 possible license plates.